All right, today's excitement is Chapter 4, Section 6. And we're going to talk about arithmetic sequences. And that's when the common difference is the same. So it's pretty much the same exact thing as a linear equation. We're just going to write it using the first term instead of the zero term. If you were to look at this table right here, how you would probably write it is you would go back to the 0 and say that 0 gives me 0 because my common difference is 0.2. So y equaling mx plus b is y equaling 0.2x plus 0, or just 0.2x. So that's your linear equation. Now, you can actually write that, just so you know, using any number. If I use the first term as my b, I would do y equals 0.2 times x minus 1, because I'm using my first term, plus 0.2, which is the first answer. Let's do another. If I use my second term, I would do y equals 0.2 times x minus 2 plus 0.4. I could do this using my third term. Y equals 0.2 times x minus 3 plus 0.6. Every single one of these simplifies to this initial equation. If you distribute and solve, you get the same exact thing as initially we had. Like, let's check it out. 0.2x minus 0.6 plus 0.6 simplifies to y equals 0.2x. Well, arithmetic sequencing, we're going to be kind of writing it in this form. And it's helpful if you're given like a couple points later in the sequence, because you don't need to go back and find the 0 and write an equation. You can just use sequencing. So we're going to start off by figuring out if it is arithmetic, which means it's linear, and if there is a common difference. So 9 to 13 is 4. And 13 to 17 is 4. And 17 to 21 is 4. So, this is arithmetic. The difference is 4. And if we continue this pattern, 21 plus 4 is 25. 25 plus 4 is 29. And 29 plus 4 is 33. All right, the next one. 10 to 8 is negative 2. 8 to 5 is negative 3. And 5 to 1 is negative 4. This is definitely a pattern, but it's not arithmetic. This has to be the same number to be arithmetic, which is another word for linear. We'll get to that pattern later this year. You'll be an expert of this pattern where the second difference is constant. Right now, let's just not worry about it. Okay, so our arithmetic sequence formula is right here. A sub 1 is the first term. N is the term number that you're on. And D is the common difference. Okay, so when we're looking at an arithmetic sequence, this is the first term. Like if you're thinking about your x's, this is the second term. This is the third term. It's not the 0. We don't have the 0. We could find the 0, but we don't need it right now because we're just going to get the 16th term. So first of all, is this arithmetic? It says it is. Let's just make sure. 4 plus 4 is 8. 8 plus 4 is 12. 12 plus 4 is 16. So let's write our formula. The 16th term, a sub 16, the 16th term, is the first term plus the 16th term minus 1 times the common difference. That's the common difference. So, 15 times 4 is 60, and 60 plus 4 is 64. If you want to think of this as a linear equation, 0 would give you 0. So our equation would be y equals 4x. And if you plug 16 in there, 4 times 16th term, is 64. So you get the same thing. This is just using sequencing. It's supposed to be easier. There's geometric sequences also, so you do need to understand how to do this with the sequencing. So we don't even have a table this time. It just says that our first term is -5, and our common difference is -2. We want to find the 25th term. So a sub 25, all that means is the 25th term, equals the first term plus 25 minus 1 times the common difference. So 24 times -2 is -48 plus -5. Remember, 2 negatives when you're adding give you an even bigger negative, is -53. So the 25th term is -53. Okay. Arithmetic. 4 to -7, we're going down by 3. Down by 3 again. Down by 3 again. Hold on to that thought. All right. So our common difference is -3. And we want the 25th term, and this is our first term. So the 23rd term will equal the first term plus the 23rd term minus 1, and we're minusing 1 because we're using the first term, times the common difference. So 22 times -3 would be -66, and -66 plus -4 is -70. So the 23rd term would be -70. Makes sense. Going down by 3, going out that far. Make sure it makes sense, because it's pretty easy to lose negatives in life. All right, this time the 40th term. So it should be a big number. We're increasing by 5. This is our first term. This is our common difference. 40th term is our n. So the 40th term is the first term plus the 40th term minus 1 because we're using our first term times the common difference. So 39 times 5 is 195, and 195 plus 2 is 197. So the 40th term is 197. If you had a table, number 40 would give you 197. 1 would give you 2, 2 would give you 7, 3 would give you 12, 4 would give you 17, and 40 would give you 197. This is kind of like an ordered pair, with that being your x value and that being your y value. Arithmetic sequencing. It's good stuff. Have a great night.